We are doing lesson 3 or session 3 of our mini bootcamp. This is the last session in Linux. And again, we have a couple of Kahoots set up for you today just to recap our learning from the last couple of sessions. So I think most of you should have it downloaded now, but if you don't, please go ahead and download the Kahoot app on your phone. So today we're going to be doing a bit of a recap from the last session, just to get our memories refreshed. I know it wasn't too long ago, but just to keep everything fresh and make sure everyone's on the same page. Then we'll talk about text editors. Many of you are familiar with editors and whatever operating system you use. And Linux, there are a couple, maybe 3 very common text editors, and we'll talk about those. And then we'll, towards the end of the session, we will get into going through some more commands, really more network oriented. So we'll do just a brief introduction to a little bit of networking and how that applies to Linux. All right, let's go. So I want to recap a few things in this first, in the next 30 minutes or so before we move on to some new material. We've talked about the shell. And again, just want to emphasize that the bash shell is common in most Linux systems that acts both as an interpreter and a programming language. It has when you look at the shell, you get a prompt, and you usually list these values, and then we showed how we can customize it using the color, or changing the color, changing the username, host, directory. And the prompt also shows you whether you're the root user or not. The command prompt, you recall, looks like this. And this was the one tricky question that we had on the Kahoot this time. And it wasn't such a direct question, but it was an indirect question. But if you type 2 file names and they don't have the same case, you try and access it with the wrong case, it won't work. Same is true of if you type a command in the wrong case, it won't work. So you have to be very careful about the case that you use and make sure it's the right case when you're typing things in Linux. Okay, so just to recap some of the commands that we've learned, to list the directory contents, we had ls, and then we looked at different variations. We had ls-l for the long view, and then ls-la if you wanted hidden files, and then ll is just a alias for ls-la. Okay. Then we had to change the current directory, you would use cd, and then you could change directory and specify a directory. You could change directory and use 2 dots to go up 1. To go to the root, you do cd and then root. And then if you want to go home, you can either do cd tilde, or you can do cd and then your root, home, root, and then slash, and then your username. Okay, so, but the easiest way to do this is to do cd tilde. If you wanted to make a new directory, you can use the command mkdir. And again, the structure is hierarchical, right? That was one of the questions in the Kahoot. It's not a flat directory structure. It's not a flat structure. It's hierarchical. And so you can make directories with the mkdir command, and you can make as many directories to whatever depth you need to store and organize your files. And then if you wanted to remove a empty directory, it's rmdir. And remember, that's not going to work unless the directory is empty. And then we had another command if the directory was not empty, which we'll cover in just a second. Then pwd to show the current path. If we wanted to create an empty file, you can do touch and then the name of the file, and that will give you an empty file. If you want to delete a file or a directory, for that matter, you just use rm, and then you can use rm and then the name of the file. or you can use rm-f. That means to force to ignore any errors and put the file. And then if you have a very elaborate directory structure with a lot of files, and you don't want to go into each directory and remove individual files from or files from individual directories and then come back up and remove that directory, then you can use the rm-rf. And remember, once it's gone, it's gone. To copy a file, you can use the cp command, and the syntax is cp, and then the source file name, and then the destination where you want to copy it to. If you want to move that same file or directory for that matter, you use the mv command, and you move from the source to the destination. And you type in the source and the destination. To show the contents of a file, and I think you guys got the idea of this in the Kahoot. Just got the case sensitivity was off, but cat is going to show you the contents of a file. And then to show a message on the screen, you can use the command echo. So for example, echo hello is just going to spit that message out to the screen, hello, without the echo. And then you can use echo and you can use cat with these redirect operators, and these will redirect, for example, to a file. So I can say echo hello and redirect it to a file and either append or erase the contents of a file and just have that output there by itself. Okay, so these are some of the most common commands that you're going to see in Linux, and hopefully they're clear to you and you understand what each of them does and how to use them. Because certainly if you're going to start doing any work in Linux, those are going to be some of the first commands you start to use. And we talked a little bit about globbing or searching for patterns, and we talked about how we could use ls for that. But we also talked about how we can use grep. So if I wanted to search for a pattern in a file, I could use this command, grep, followed by the pattern, followed by the file. And how do I make the patterns? Well, I create patterns using special syntactical constructs. So for example, if I wanted to match a single character, then I would use question mark. So if I want exactly one character, any character, then I'm just going to use question mark. Okay, so it's not 0 characters, it's not 2 characters or more. It's exactly one, and it's any character. So if I do file question mark.txt and I put an ls in front of it, it's going to return to me file 1, file 2, file 3, file 4, file A, file B, all .txt. Now, will it return back to me file 10.txt? Yes or no? File 10. No, it will not return file 10 because file 10 has 2 digits, 1 and 0. And I'm just asking for 1 digit here. 1 character, any character, just 1, exactly 1. If you don't know how many characters you want to match, or you want to match more than 1 character, then you use the wildcard, and this is any character and any number of characters. So this is going to return me, if I put an ls in front of it, it's going to return me every file that starts with an A, has any number of characters after it, then a dot, and any number of characters after the dot. Okay. And then a variation on the single character is if you use the square brackets with a particular set of characters. So if I say square brackets, A through a capital A to Z, and then lowercase a to Z, close bracket, this will match exactly 1 character between either lowercase a to Z or uppercase A to Z. So it won't match the number 1, won't match the number 5, It will match uppercase B, it will match lowercase b, but it'll only match one character. Okay, so a couple of different options when you're trying to match specific characters. You have the wildcard when you want to match more than one character or any number of characters, or any character for that matter. Okay, and then you can use grep if you're searching in a file. You can use ls if you're just listing the contents of a directory. So you can use these kinds of patterns in different ways. All right. So one thing I wanted to pick up on today was the file permission. So we're going to cover that in just a couple of minutes because we ran out of time at the end of the last session. So I wanted to go over that because that's very important to understand. And so before we go back to the file permissions, I just wanted to quickly recap the files and directories themselves and the structure. So you remember last time we talked about this, the standard in Linux called FHS, which stands for File System Hierarchy Standard. Again, it tells you that the file system is a hierarchy, it's a tree, okay? And all of the files and directories are going to appear under the root directory, even if they're stored on different devices. So I can have a disk that's a network storage device, but it will still show up under the root directory, or I can have different devices, printers and so on that would show up under the root directory. So it's in Linux, everything shows up under this file system hierarchy. Okay. And most of the directories that we're going to talk about and look at are true. They exist, or sorry, they're going to exist in any kind of Unix system, but this FHS standard is authoritative for just Linux. All right, and then we looked at the various files and directories where files are stored, and it's not critical that you remember or memorize all the little details, but at a high level to understand where certain things are kept. So when we did the Kahoot, we had this question about the log files. You should be able to tell from the name of the directory where it might or might not live. Okay, so I've grouped them in bundles where they make a little bit of sense, or where you can group them together. So the first four are, let's call them system type directories. You have the boot /boot, where you have the bootloader files, and then your devices are under /dev. And then when you have temporarily mounted file systems, like I said, a network storage device, it would be under /mnt. And then information about the system itself under /proc. Okay. And then you have program files. So bin and sbin are going to be where the binaries are. And again, a binary is what? A binary is nothing more than a program, an executable. That's the thing that actually runs. It's the command, it's the program that actually runs. So bin are the command binaries, and then sbin are the system binaries. So you would, for example, in the question we had, you wouldn't expect log files normally to be kept where binary files are. And then lib are common libraries. So these binaries often need, or they share libraries, and which are also some form of executables or a form of binaries, but they sort of underlie the executables. And so those libraries, those shared libraries, are kept in the /lib folder. And then anything that you install that's an optional package from another vendor, or somebody else installs something, is going to be kept in the /opt for optional directory. All right, then we've got the root directory for the root user, and then all of the user home directories are under /home. slash Etsy or etc. is historically where everything else that didn't have a place was kept. But these are typically now configuration files that are specific to the environment that you're running on. And then var will contain variable data files, or in other words, files that change as the system runs. So log files change. Log files, if it's not obvious what they are, this is where when a program runs and it keeps track of every action that takes place, it keeps track in those log files. And that's what log files are. And they're helpful in helping people debug issues or find out if you have a problem, what that problem might be. And then slash temp or TMP is where temporary files are kept. Okay. Any questions about any of that so far? All right, good. All right, and then just a little drilling in a little bit to a couple of these other directories. We have the slash home directory, which, as I mentioned, are going to be the user home directories. But then each user, in this case, student, in this case, Linux Gym, can create more folders underneath. So this hierarchy can just go to whatever extent you need it to go to organize your files. And then when you have multi-user applications and utilities and applications, they're going to be under this slash user folder. And there you're going to have slash bin slash sbin and so on. So it's going to have a parallel hierarchy for the rest of the system. But this is where you have, this is for multi-user utilities and applications. So we're a little bit ahead, so why don't we just continue on here and talk a little bit about file permissions. All right, and again, some of this is recap, but towards the end, we're going to do a few exercises and just come back, because I know towards the end, we kind of ran out of time there when we were talking about permissions. So when we look at, so we talked about this hierarchical structure, and the system is used to store files and directories, but it's very important to assign permissions and ownership to all of those files for a lot of reasons. And we talked about some of those reasons last time. And so the permissions are assigned based on three entities or three levels of ownership. One is the user permission, one is the group permission, and then the third is everybody else who's not in the group or not the user, okay? You can have the user, the group, and everybody else. And what permissions do each of these entities have? Well, they're going to have one of three permissions. They're going to have permission to read, they're going to have permission to write, or they're going to have permission to, or they're going to have permission to execute. So you can have none of these, one of these, or more than one of these for any file. Okay. All right. So if we look at the actual output of the ls command or ls-l command, what we see here are the permissions on the leftmost side, and you can see there are 9 + 1, 10 spaces. So it's split up into 3 groups of 3 + 1. So the 3 groups of 3 are the permissions for the, sorry, let me start from this side. Permissions for the owner, permissions for the group, and then permissions for everybody else. So for each of those entities, there are 3 options: read, write, execute, read, write, execute. Okay. And then the very first position, or the leftmost position, tells you whether or not it's a file or a directory. So if it's just a hyphen or dash, that means it's a file. And if it has the letter D, that means it's a directory. So again, there's only one of 3 characters that can be in these 9 spaces. It's going to either be read, write, execute, or dash. And dash means you don't have permission for that particular item. So either read, write, or execute. Okay. And then the first character is going to be either a D or it's going to be empty. All right, so let's look at this a little bit closer. I've highlighted these 3 groups here, right? So you've got the user, the group, and others. And there's a few different ways to look at this, right? You can kind of memorize this table, or you can look at this table right now. And you can see that if you've got 3 dashes, right? And remember, there's only three spaces for each particular entity. So if I've got 3 dashes, that means no permission. So as an example, for others here, on this file, cert.pem, the others have no permissions, and the group has no permissions. Yeah. Then there's the --x, which is execute, right? So in this case, there are no users or no entities, no identities here that have a --x. But if you see a --x, it means I only have the permission to execute. And execute usually goes along with a program or a binary, which is why in this particular example, there's no execute. Then you've got write-only permissions, okay? And it would be a little bit uncommon to have only write permissions. Typically, if you're going to have write permissions, you're going to have read permissions as well. But it's not impossible to have write. But you can see there's no file here that has just write permissions. Then if I have -wx, it's going to be execute and write. Okay. And then this is going to be a common one. You know, this means read-only permission. So r --. So you can see there's a few different places where that shows up. So the user here, the user or the owner of this file itself, himself or herself, has only read permissions here. In the case of this file, the group and everyone else has read-only permissions. Okay, and just a reminder that, does anybody recall what kind of files are these that start with the period or the dot?
Hidden files?
Yeah, these are hidden files. So if I just do ls -l or just ls, they wouldn't show up. If I want to see them, I actually have to type ls -a or ls -la. Okay, so that's read only. Then I've read execute, and you can see again, that's not I mean, that would be a very common permission to have. So you can see in fact, for the directories, the group and others have read and execute permission. And then read write is another common one. So you can see the user here, the owner of the file, has read write permissions for these files here. And then full permissions is going to be read, write, and execute. And you can see here for this directory, everyone has read, write, execute permissions. Okay, so it should be, it should be kind of intuitive or obvious what these are and the way to read them. But this is the table that corresponds to each of those permissions or those groups of permissions. We started last week talking about how these correspond to numbers, okay? And if you know the binary system, then this will be obvious to you. If you don't, it doesn't really matter. You just have to remember 3 numbers: 4, 2, and 1. 4, 2, and 1. Okay, and to figure out what the permissions are, you simply have to add that number where there's no dash. So in this case, I have a RWX, no dashes. So I'm going to add the 4, 2, and the 1, and I get 7. Same thing here, RWX 4, 2, 1, I get 7. Same thing here. Okay, but look at this example here. Here I've got RWX, so that's 4, 2, and 1, that's 7. Okay, this one I've got 4. I don't add the 2 because there's a dash here, so it's just 4 plus 0, and then I'm going to add the 1 because I've got an X here. So that gives me 5. I got 7 here, I got 5 here. And then in this case, I have 4. I have nothing here because it's a dash. And I have nothing here, again, because it's a dash. So 4 plus 0 plus 0 is going to give me 4. So I can look at the permissions for this particular file, or in this case, it's a directory. And I can say it's read, write, execute, read, execute, and read only. So I could say that. Or I could just say that the permission on this file is this number, 754. Okay, and you'll see when we get to the commands to actually change permissions, why this is sometimes a lot easier. But it just boils down to being able to translate from the RWX convention or nomenclature terminology to these numbers. And it's as simple as just remembering these 3 numbers and remembering that you have to add them if there's something there and not add it if there's nothing there. So like in this case, we're not adding the 2, and in this case, we're not adding the 2 or the 1, and so we end up with just 4. Okay, and for those of you who understand the binary system a little bit, or how binary numbers work, this is the 2 to the 0 placeholder, which is 1. This is 2 to the 1 placeholder, which is 2. And this is 2 to the 2 placeholder, which is 4, which is why we have 4, 2, and 1. Okay. All right, I'm going to pause there. Any questions about the permissions that you can have, or how you convert from the RWX to the numbers? Is everybody clear about that?
Yes.
Yeah. Okay, I hear one person's clear about it. Okay. All right, good. So we're at 7:45, so let us take our break right now and come back at 8 o'clock, and we'll continue with file permissions and then go forward from there. All right, I'll see you in 15 minutes. All right, so we were talking about file permissions. Looked at that table, and we finished going through this. So 4, 2, 1, those were the 3 magic numbers. You have to remember and just add them up. And so you can also work backwards from there. If you have just the 4, 2, and 1 in your head, we didn't do this one, but you can work backwards. If somebody says your permission is 764, what does that mean? Well, 7 is going to be 4, 2, and 1. So that's read, write, execute. 6 is going to be 4 plus 2, which is read and write. And 4 is just going to be 4, which is read. So you can go both ways with these numbers. And, you know, it's helpful to be able to do that. All right. So why is it helpful to know what those numbers are? And why did we spend the time looking at the numbers, and how does it help you? It's not just a futile exercise. So the reason it helps is when it comes to setting permissions, because obviously when you're reading permissions, it's right in front of you. Read, write, execute, read, write, whatever it is, it's right there in the directories when you do your ls or your ll, and you can see exactly what the permissions are. But when you want to set the file permissions, we use this command called chmod or change mode, and this allows you to set the file permissions, read, write, and execute for the same three entities, user, groups, and everyone else. So there's a few different ways to do it. So the first way is to explicitly set the permissions for each entity. So I'm going to say chmod u, so user or the owner, is going to be R, W, and X, read, write, execute. For the group, it's just going to be read and execute. And for others, it's just going to be read. So you do that, and then you tell it which file, my file. So that changes the permissions for that file to be read, write, execute, and read. But that's a lot to type in. And so this is where the numbering system comes in handy. If you're able to very quickly do that calculation in your head, so you look at 754, that's going to be read, write, execute. 5 is going to be 4 and 1, which is read and execute, and 4 is just going to be read. So this is read, write, execute, read and execute, and read, right? 7, 5, 4, my file. So rather than having to type all of this out, you just do chmod 754, my file, and it's going to set it to essentially the same as this. Now, the other way to do it is to say, well, I don't want to have to specify everything all the time. Sometimes I just want to change certain permissions or add a permission or remove a permission. I don't need to specify the whole thing all the time. Sorry, someone has a question? No? Okay, so if you don't need to change the whole thing, what you can do is specify the entity, in this case, others, and what you want to change. So it can be a plus or a minus. In this case, I got a minus W on my file. So I'm going to change the permissions for others, and I'm going to take away the write permissions. That's what the minus W means. Or in this case, for others, I'm going to take away the read permissions. So if I wanted to, let's say, for example, I wanted to add execute permission for the group, how would I do that? I would do chmod, then what?
chg plus
G, yes.
the
Plus
plus.
what? Mm-hmm. G plus what? I need one more character at the end of that.
Can you please repeat the question? We want to add which write to the group?
Execute.
So it
Then
would
X.
be G plus X.
Yeah, thanks for both of you. Yes, chmod G plus X. Okay, so that becomes easy. I don't have to remember I don't have to know or remember what the permissions were or retype the whole thing. I can just do a minus or a plus and put the symbol for that particular entity. Okay, so a few different ways that you can do it, whatever works for you, but all of these would be used, and it's helpful to these I would say are probably more so the 3 bottom ones than the top one, and so that's why it's helpful to remember the numbers. That's why you'll see sometimes if you guys have ever or if you've done some reading in the last little while as you're taking these Linux courses, or you've seen sometimes when you have to connect to a machine and someone will say, change the permissions to 600 or 660 or 440. That's what those numbers are referring to. Okay. So just to show you an example here, and we're going to go through a full exercise in just a minute. But in this case, you can see that this user has typed ls minus L, okay? And then for this file, file 2, they've changed here in this line, they've gone ahead and changed the permission to 754. So what's the number here right now before we change it? It's going to be 4, 4, read write 447, right? That's the permissions before we start. And then after we start, it's 754. And when you do an ls minus L, you see it's 754. Okay. And then this is what that means, that the owner can read, write, and execute. The user's group can only read and execute, and others can only read. And then you can see that I could have done the same thing this way. Okay, so let's do exercise together. I'm going to just pull up my Ubuntu screen, and let me see if I can split screen here. And as I mentioned to you guys last week, there's the Windows subsystem for Linux. So if you have this installed, you can do it on your own while I'm doing it here, or you can just watch and just think about the answer. So I'm gonna make a directory. I'm just gonna call it session 3. Okay, and I'm going to go into that directory session 3, and I want to create a file. So what am I going to do to create a file?
Touch.
I can touch my file.txt. Okay, so if I want to see the permissions on that file, I'm going to do ls minus L. Okay, and so it's read, write, read, and read. So that's 4 and 2, 6, 4, 4. So the permissions right now are 644. Okay, so here, this exercise says the starting permissions are 777. So I'm just going to do that. Okay, now if I list this, or yeah, list this again, you'll see it's 777. Now I want to do each of these in a slightly different way. I want to do each of these in a slightly different way. So there's multiple ways, like I showed you, to change permissions, but to show you all the different ways, I'm going to do them all slightly different. So the answer that you have might still be right, but might not be the one I use. Okay, so the first thing it says, the owner is going to have full access, the group is going to have read and execute, and others no access. So the first way I can do this is I can say, so actually user is full access. So read, write, execute. Okay, and then we want the group to have read and execute. And we want everyone else to have no access. Okay, and then I'm going to do my file. Now, if I list it, that didn't work, right? Because I didn't change the others. So the other way to do it is I can say, I can do basically use the numbering schemes, right? So I can say ch full access is going to be 7. Read and execute is going to be 4 plus 1, which is 5. And no access is going to be
0.
0. Okay. So now I have read, write, execute, and nothing. Okay, all right. So let's start with this one here. It says the starting permission is 777 again. Okay. So it says remove read and write access for others. So I just want to remove the read and the write access for others. So there's no point me typing in more than I need to. I just want to remove read and write for others. Okay, so I just did the minus RW. So minus RW for others. They no longer, others have no longer the permission to read or write. Right? Okay, so that one's done. Okay, so it's start out with 666.
Can I ask a question there?
You sure can.
I probably missed what you wrote, but when you take the write back, you put minus read and write. But before that, it was 0 or O.
This one here, the first one.
I can't see now. Your screen only shows last 4 lines.
No, can you see the right side of my screen?
Okay, sorry.
You're talking about this first one?
Oh, owner. Okay. Never mind. Sorry.
Yeah, I should.
Yeah, you took back the right from owner. Okay.
Yeah, I should say user here. It'll be easier. Okay, it's okay now. You understand?
Yes, correct.
Okay. All right.
Thank you.
Okay, so now I'm going to start with 666 here. Okay, 666, read write for everything. Add execution permissions for owner, group, and others. So I want to add execution permission for everybody now. So the easiest way to do that is you don't specify any entity, just chmod plus X. That's going to do it for everybody in my file.txt. Okay, so now I added executables for everybody. So it edited for everybody here. Okay. All right. Then the last one says user read and write, group execute, others execute. So again, lots of different ways to do this. You could do read write, group execute, others execute, my file.txt. Okay. So you can see that there's a lot of different ways to change the permissions. Whatever's simplest, whatever makes sense, that's what you're going to want to do. But it's helpful to know all these different approaches. Okay, this is kind of the brute force longest way to go about it, and then other things like this where you just add X for everybody, or you just add a specific permission for a specific entity, just makes things more efficient. Okay. Oh, okay, you got that sorted out. Okay, we talked a little bit about, well, we're going to talk about text editors. Now, in any operating system, and again, I'm assuming most of you are either Windows or Mac users, you have some way to edit text files. Notepad or, text or, some kind of editor. And again, you have to remember that Linux dates back some time, and some of the distributions of Linux, many of them don't have a graphical user interface, a Windows type interface. that allows you to start up programs and use the mouse effectively. And so when you're using Linux, you sometimes have to get used to using the command line a lot, as opposed to your mouse in a windowed system. And text editors are kind of the same way. You have to it kind of takes you back to a different time, but that's just what you have access to. And if you're going to be using Linux, you need to get familiar with them. So we're going to talk about a couple of different editors. I think you're going to prefer the second one, if I were to guess, compared to the first one. Although first one is very, very common. A lot of people use it, and people who've been working in Linux for a long time swear by it. So when you start up Vim, and I'm going to open it up and we'll see how it works. You won't be able to see me hit the keys, but I'll talk you through things as I'm doing them. But when you open the Vim editor, you start in a command mode, which means that it's waiting for a command. It's not like if you start up a word processor or a text editor where you just start typing. You can't do that. It's waiting for a command. And so in order for you to type something, you have to go into insert mode. And you do that by pressing the I key, the key I. And then you can start typing. And then when you're in that mode, you can type whatever you want. And when you exit the mode, when you exit editing mode and you go back into command mode, you can move your cursor around the screen. You can type certain commands, but you can't enter text. Okay. Like I said, it's very powerful. And it takes a lot of getting used to. But here are some of the commands that are the common ones. So if you get to a point where, you need to use Linux, or it's something that you have for a project or anything like that, here's some of the most common commands that you're going to want to use. So as I said, when you start it up, you are in a command mode. So to get into insert mode, to edit mode, or insert mode, you have to type the I. If you're in edit mode and you want to go back into command mode, you hit the escape button. Okay. You can do lowercase x to delete, uppercase X to backspace delete, or lowercase u to undo changes, Control R to redo changes. YY does what's called yank or pull or copy. It copies a line, and then DD will delete the line. Okay, so and then P will put the line or paste the buffer back. To go to the bottom or the top of the file, you can use these square brackets twice, or you can use GG or G. And then this is the command if you want to search. And then to save changes or write the file, you hit escape, you get out of edit mode, and then you do :W. W means write or save. And then if you want to write and quit, then it would be escape, the :W and Q, and you're out of the buffer. Now I know this seems a little bit bizarre, especially if you're not used to using Linux and you're in Windows or Mac and you're pressing the save button and you just type things and you can highlight things and search for things. But like I said, it's these things have a history, and it's evolved a little bit. But when you're in Linux, you just have to get used to working with these tools. So let me pull up an editor here. Okay. So, and let me go up one directory. And let's just pull up this file called test. Okay, so as I said, when you open it, you're in command mode. So I can go up and down and move around the file. So now I'm going to press the, let me actually pull up the, let's see if I can do it in. I'm going to do it in, so I'm at the top now. I'm going to press these 2 square brackets here. And you see it takes me to the end. Now here it's a small file, so it doesn't matter, but sometimes you might have a file that's, 1,000 lines or a few hundred lines, and I'm going to press the other square brackets and it's going to take me to the top. Okay, now all of these commands here work in command mode. Okay, so you have to be in command mode to use them. So for example, if I want to delete a character, I just have to press X. I'm going to press X here. Oh, I didn't want that. So I'm still in command mode. So I can just press U and that will undo it. Okay. Or let's say I want to copy this line here. Okay. I'm going to press Y twice. You can't see me, but I'm telling you I pressed it twice. And now I'm going to paste key. Okay. So I can do any of these commands, but if I try and delete, like I'm pressing the delete key right now, it's not going to work. But if I press the X, I have to do it from here. X will work. Okay. Oops, I tried to type in E, it didn't work. Okay, so I'm going to do the undo, which is just U, and I'm going to do U again, so it does the undo. And I want to delete this blank line, so I'm going to do a D, or double D, DD, and it deletes the blank line. So that's all in command mode. But I'm going to type, maybe you can hear, oh, did I already, I pressed the I. Okay, I'm going to go back into command mode and I'm going to just start typing. When I press the I, it does that. So if I want to actually start typing something, then I can go to the end here or wherever I want to go. Now you see, can you see here, it says insert. So I just press the I and that's why I get the insert. So now I can start typing echo, this file is new. Okay, so now I've typed whatever I want to type. I'm going to press escape to get me back into command mode. Okay, so you can see the insert is gone now. Now, if I want to save it, I can do WQ. So that's this. Okay, or if I don't want to save it and I just want to exit, I can just do Q, an exclamation mark, and it will quit without saving. So if you make some changes and you think, oh, I didn't want to save it, then you can just quit like that. Okay, so again, not always so intuitive, but this kind of small set of commands, just knowing them, knowing those is going to help you be able to navigate Linux and at least use it, kind of use it to a degree where you can get around. Okay, so a few commands, and you can always look these up, but these are a good small set of commands to remember for Vim. Then there's another one, which, like I said, I think most of you are going to prefer, and that's called Nano. Okay, so Nano is a, they call it a friendly text editor, but it also offers, other features like this, including line numbers, indentation, interactive search and replace. So let's take a look at that Nano now. And in that case, I don't need to split my screen because there are no commands to remember. So I'm going to just open this file with Nano. Okay. Oh, it looks like I did mess up this file. Let me just, well, actually, it doesn't really matter. So right here, you can see at the bottom, essentially the menu or the all of the various commands. And this little caret, you can access that with Control, and the M you can access with Alt. So you remember, or actually, I didn't do an example of searching, but you remember with Vim, this was how I needed to search, right? You have to remember this: colon, %, foo, and then this is the thing you're searching for. This is what you want to replace it with, and then G means global. So I don't have to do any of that here. So I can just do a where is, Control W. Okay, and it's saying, what do you want to search for? I want to search for this thing. Okay, and it finds it. Okay, or I want to replace. So replace is Control \. Okay, so it asks you, what do you want to search for? Well, I want to search for the word read. What do you want to replace it with? When I want to replace it with read. Okay, and then it tells you, do you want to replace this instance? Yes, no, all, or cancel. So if I do yes, it'll do just this one. No, it won't replace it. If I do A, capital A, it'll do all of them. Okay, and it just replaces all of them. I can undo with Alt U.
Can I ask a question, please?
Yeah.
So now when we searched for read, it highlighted the second one. And if we press no, does it take to the first one, or it does nothing?
Okay,
For the search and replace.
I can do that. So Control \. So I search for read. And I'm going to replace it with read. And you said, okay, highlight the second one. If I do what?
Now the second one is highlighted, right? So if it's saying replace this instance, supposing if I want to replace the first instance, so how do I do that? So should I select a no, or how is it?
Yeah, so I'm going to select no here. Then it goes to the first one, the next one, which is, it wraps around. And now I can do yes, and it'll replace that one.
Okay, got it. Thank you.
And now if I want to undo it, I just do the Alt U, and it undoes what I just did. So, the menu of commands is here. It is a lot easier. You don't have to remember many things like you do with Vim. So I suspect that, this would be something a little bit more user-friendly, and especially if you're starting out in Linux, easier to use. All right. Okay, so we're going to come back and talk about a little bit of introduction to networking and do some networking commands in Linux. And I will see you here at 9 o'clock after this 15-minute break. All right, so grab something to drink, eat, whatever you need to do, and I will see you shortly. All right, let's get started. Last 45 minutes of your intro to Linux. Hopefully this has been helpful and useful and interesting for all of you. Down to, like I said, the last 45 minutes, we're going to talk about a little bit of a few other commands, helpful commands and debugging and diagnostics in Linux. But in order to explain those to you properly, I just want to talk a little bit about how devices or servers or computers talk to one another, and then we'll be able to get into those commands and how they're useful and when you use them. So the first thing to understand is that is this whole notion of IP addresses and domain names. Normally, when you access devices or sites or servers, you're accessing them by domain names, right? You go to Clarusway.com or Amazon.com or Google.com. They're domain names. They're easy to remember. But that's not how machines or computers or servers talk to one another. They talk to one another based on what are known as IP addresses. IP stands for Internet Protocol. And so every device on the internet has an IP address. It's like it's unique address, just like your address for your home is unique. It has a street number, a street name, a city, a state, a zip code. That makes it unique. Similarly, every device on the internet has a unique IP address. And that's the way one server finds another server. So the question is, if you communicate with a server using its name, its domain name, but the server can only talk to another server using an IP address, how do we translate between a domain name and an IP address? All right. So there's something called DNS, or domain name system. And there are DNS servers around the world that do this translation. And so every time you have a machine over here that wants to access another machine, so for example, this machine wants to access google.com. So it first has to make when you search for google.com, the first thing that this machine does, you don't see it, but the first thing it does is it makes a DNS request. And that DNS request goes to a DNS server, okay? And the DNS server is essentially a lookup, and it says, oh, you're on google.com, and it has a list of all the different domain names and the corresponding IPs, and it sends back the IP address for google.com. And now your machine's browser can talk to the Google server. Okay, so under the covers, behind the scenes, this is what's happening. And so if you want to take a look, for example, all of you, I'm sure, have a browser in front of you of some sort. But if you go to, just type in Google, what is my IP? Okay, and well, Google gives it to you right there, but there's the site, what is my IP address? You can see that here also. And this is what your IP address is. Okay, every computer has an IP address, and that is the address of my computer. This is how it gets to me. Okay, so and if you do that in your browser and you're using Google, you'll probably see this, and that will be your IP address. And there are actually commands in Linux where you can get your IP address. And sometimes you're going to have multiple IP addresses, and because you're sitting on different networks. But if I do this, it's called ifconfig. I wasn't planning to go through this necessarily, but since we're here, I'm on different networks. I'm on a couple of I'm on an internal network, and so that's giving my internal IP and another internal address. And every computer can loop back to itself. So every computer also has an IP address of 127.0.01. That's always your computer's IP. It's a loop back. It's how your computer can talk to itself if you ever need it to. Okay. But there are internal IP addresses and external IP addresses depending on what network you're on, because when you're inside an office or an environment and your computers need to talk to each other in that network, it's different than when computers have to talk to each other externally around the world. So you're going to have, in fact, multiple IP addresses for each network that you're on. But the point is that there are IP addresses, and each of your servers or devices or computers has an IP address. And sometimes there are computers out there or servers that have domain names. So not every server has a domain name, but everyone has an IP address. Sometimes you want to convert between the two, and you do that by doing a DNS query or a DNS lookup. And there are servers all around the world that do these DNS lookups for you. So one of the commands that you can use is this thing called NSLOOKUP. So NSLOOKUP is used to perform DNS queries. And what you'll do is when you do NSLOOKUP, you get the address, the IP address of the domain that you're looking up. Okay. And NSLOOKUP is using the default DNS server. So like I said, there's lots of different DNS servers that you could be using. And there's so many out there just for replication and high availability. So if one goes down, you have another one. But it's using, and everybody has their own default DNS server that your computer is using. I won't get into how it's assigned, but everyone has their own DNS server. Okay. And so the syntax of NSLOOKUP is just like this: NSLOOKUP and then domain name. Now, in Unix and Linux-based systems, more so people are using dig, and you essentially get the same result. So if we go here, let's just do this. I can do dig Clarusway.com. Okay, so you get the IP address, and in fact, a lot of these domains have multiple IP addresses, and so you're getting sorry, I clicked something that confused me. There are multiple IP addresses for a domain, just in case you can't reach the domain through one IP, you can get there through another one, or another one, or another one. It's just to provide redundancy in case something happens to one of the servers. And so you can have multiple IPs for one domain, and if you go to any of these IPs, it will be the same as if you were to go to another one. So that's clarusway.com, and that's dig. But like I said, you can also use NSLOOKUP. If I use NSLOOKUP, let's do Google or Yahoo. Let's say Yahoo. Okay. And you can see it comes up with multiple IP addresses as well. Okay. And then I haven't covered, these are different types of IP addresses, which I'm not going to cover right now. It's beyond the scope, but you can see there's an IP address. So the point is that there are servers that you need to talk to, and you only know their names: yahoo.com, clarusway.com, google.com. You don't know the IP addresses, but your computer cannot talk to a server just based on name. So there's always a lookup that your browser does. And if you're on a Linux system and you ever need to do, you know, this kind of diagnostics, or you need to look up what a IP is for a given domain, you can use NSLOOKUP or dig.
Can I ask a question here?
Yes, yes.
I did the dig for clarusway.com, and my answers are different than yours.
Oh, wow. Okay, what did you get?
Did I do something wrong? I've got like 143.204.151.100. Interesting.
Let me try something around. Can you type this in exactly the way I've typed it? NSLOOKUP Clarusway, and then do 8.8.8.8.
Okay. Same, still the same.
You get a different answer?
Yeah, 143.204.151.100.
Oh, okay. I
Interesting.
don't know. Sometimes it's related to your ISP. I know I was having different issues when I was with, I think I was on Cox. Yeah, I don't know the answer to that question right now.
Okay.
It is a little bit odd, but it might be related to your ISP. The reason I asked you to do this is because this looks up. Remember I said there's different DNS servers. This is Google's DNS server, and it's a common one that sometimes you can use to test. So I was just checking to see if you were using a different DNS server, and for whatever reason, it was coming back with the different IP. But let's see if we have time at the end. I'll dig into it a little bit, but I'm not sure right now why you have that. It's a little bit weird. Yeah. Okay.
Thank you so much.
Okay, mine is as well. Mine is different as well, and
different
than hers and yours.
Okay. All right. Very interesting. Okay. Yeah, I cannot explain that. It's supposed and should come back with the same. Definitely should come back with the same IP address.
Is it something with dynamic IP address or not? Like each time uses different IP? No.
No, that's what these four. That's why you have four of them. It uses.
Oh, okay.
It uses one of those four. We're going to do ping next.
Okay.
So, okay. Let me think about it while I'm talking about some of this other stuff, and we'll see if we can figure it out. But I'm not sure. Okay. Okay. So, anyways, when it's supposed to bring back the IP address, and when we get to ping, we'll see if we come up with a different answer. And you guys are both where are you located?
I'm in Turkey.
I'm in New York.
Okay. I'm in DC, so I would expect to at least New York and mine should be the same. Okay, let me think about it. Okay, so in any case, so this is how you get the IP address. Okay. And this is kind of what the output looks like. It's a little bit different than dig than it was with NSLOOKUP, but you can see with NSLOOKUP, this is what you get. This is what you get back, and you can see this is when I had done it on my FiOS, and yeah, I got a different response with FiOS than I'm getting right now. So, all right. So this is the DNS server that's returning your request. This is the domain name that you were asking for, and those are the IPs associated with that that particular domain. Okay, so now we understand that we've got a domain name, we've got a IP address, and the devices, the computers, the servers only talk between IP to IP. So the question is, now you've got an IP to IP connection, right? So it's like picking up the phone. I'm going to pick up the phone. I'm going to, or get the phone. I'm going to dial a number. And now the only way I can reach you is by your phone number, right? Like I know your name, so I type in your name, but my phone does a lookup between your name and your phone number and connects my phone number to your phone number. So now I've got a connection. But how do we talk to one another now, right? There has to be some protocol that's established so that we can have a proper conversation. So maybe first I say hello, and then there's somebody on the other line, so you say hello back, and then I can ask you a question, do you have the time? And then you tell me the time. And so there's this kind of a protocol. If I want to have a meaningful conversation with you, there's a way we talk. We can't talk over each other. You're going to answer my questions. I'm going to ask your questions. So there's a protocol. So similarly, there are network communication protocols. And a protocol is just that. It's just a set of rules on how the data is going to be exchanged between two devices or 2 servers or 2 computers, and they're very complex. It's not, the protocols are quite complex because they, will allow for encryption so that the, people can't just read the, see the data and see what's, what you're communicating back and forth with. It has to allow to make sure it's high speed. You have to make sure that you don't lose parts of the conversation. When your network is not good and all of a sudden you hear every third word I say, that's not helpful, right? And so these protocols allow to, retransmit packets when packets are dropped, so that the entire conversation or the entire communication is maintained. And so the protocols are a set of rules. They're not trivial, but it's enough to understand that there is a protocol. Now, some of the common protocols, like one that you use every single day, is HTTP or HTTPS. And that's the protocol that your web browser uses to talk to a web server. And if that protocol didn't exist, then you couldn't read a web page. You couldn't get the information on a web page in your web browser. So again, if we go back to how does your browser work, does the DNS lookup, gets the IP address, the IP address connects to the IP address of the server, then the based on that protocol, because it's using the browser, they start exchanging information. Okay, give me your home page. Here's the results of my home page. It returns the home page. The browser knows how to interpret that and display it on the browser. And all of a sudden, you're looking at a pretty website. Okay, so HTTP, HTTPS are common network protocols. The other protocol we'll talk about is something called SSH, secure shell. We talked about a shell. So secure shell is going to be related to that. It's going to essentially allow you to securely connect to a remote machine. So the shell, when I opened up the shell here, it's on my local server or my local machine or my local computer. With SSH, secure shell, I can connect to a shell or open a shell session on a different computer or a different server. Now, why would I want to do that? Well, you're not always going to have your access to your servers where you sit, right? Most of the servers that run systems, whether they're running the internet, whether they're running your corporate environment, whether they're running anything else, they're not going to be sitting, or they're not going to be in your vicinity, and they're going to be people working on these systems from a lot of different places. And this has nothing to do with COVID. This was all, long before COVID. It's just that the servers are not located normally where everyone is. They're in, areas where, in special facilities and areas that have the right cooling, that have security, where the devices are protected, all of that. So you need to be able to remotely access those servers. And so with Linux, typically the way it's done is using the SSH protocol, and we'll see that shortly. So these are common protocols that you'll use: HTTP, HTTPS, and SSH. Okay, and again, both of these, all these protocols under the cover, need to first establish that connection using the IP address. That's why the IP address is so important. Okay, so let's look at two commands, ping and SSH. So ping is, it's installed literally on or virtually on all Linux distributions. In fact, it's installed on Windows, it's installed on Mac. Pretty much any operating system you access, a common operating system, is going to have a ping utility. And it's one of the most basic TCP/IP utilities for network troubleshooting. And TCP/IP just refers to the overall protocol of how computers talk when they're using IP addresses. But essentially, it's the most common, not common, it's the most basic tool. It's kind of one of the first things the first things you try to do whenever you have problems in connecting between two servers is ping. Okay. Now we talked about different protocols: HTTP, HTTPS. There's another protocol which is known as ICMP, and ping is using this ICMP protocol. Okay, and so when you ping a machine, and you'll hear this term, people use this term, I'll ping this machine. Can you ping this machine? Will you ping this machine for me? When you ping a machine, it is sending an echo request using the ICMP protocol. When the destination machine gets the echo request, it sends back an echo reply. But just like if I have a browser on one end and a web server on the other end, they both have to understand HTTP and HTTPS, and they both have to have HTTP enabled. Similarly, if I want ping to work, then the other server and the server that I'm on have to have this ICMP protocol enabled. Okay? If you don't have it enabled or it's blocked, then the ping won't work. So what is the use of ping? Well, it can confirm for you if a host is running. If I ping a host, or I ping a server, or I ping a machine that's not mine, another IP address, and it responds, then I can tell you for sure that it's up and running. So if I want to know for sure if it's up and running, I can ping it. But what it can't tell you, it can't conclusively tell you that the host on the other side is down. It can't tell you if that host isn't up and running. Well, why not? Well, if my network was not connected, if I'm not connected to the internet and I tried to ping Google, it won't work. I can't get my request all the way over to Google. It's not a problem with the remote server. There's something wrong with my server. Or what if the remote server doesn't, there are many servers that turn off ICMP because they don't want random servers pinging them. Because that's also a way to, determine if a server is up, if it's running, what the IP address is, all of that kind of thing. So some servers turn off ICMP. So if that remote server has turned off ICMP, then your ping request will never get a response. So ping is a useful tool. It's, like I said, the most basic tool to determine if a server is up and running, but you cannot say for sure that the server is down, because there's lots of reasons why you wouldn't get a response back other than the server being down. Okay, does that make sense?
Yes.
All right, good. So the syntax for ping is pretty straightforward. You can do ping and the host name, or you can just do ping followed the IP address. So if you have the IP address, you can do that. If you don't, you can do the host name. And if you do the host name, what happens? Well, it's the same thing that would happen as if you were, or as when you go to your browser. First, ping is going to do a DNS lookup. It's going to get the IP address based on the host that you just pinged, and then it will come back with the IP address, and then it will send a ping to that IP address. There's no way for two servers to communicate based on host name. That's just something that we use. It makes it easier, but whenever there's a host name, you have to do a DNS lookup. So it's the same kind of a thing. Okay. So if we walk through the step, if we go step by step, how does it work? So the first thing is, if it has to, it resolves the domain name to an IP address. It does a DNS lookup. If you put an IP address, it doesn't have to do that, but if you put a domain name, it will. Then it starts sending, or it sends an ICMP packet to the destination IP. If the destination IP is reachable and ICMP is enabled, it'll come back, it'll send an echo reply, okay? And then the ping command will print a line that includes the number of bytes that it just sent. Okay, and a byte is essentially the smallest size of information that can be sent over. And so typically it's going to send 64 bytes, or you can think of a byte as a character. It'll send 64 characters. It'll print out the host name and or the IP of the address and or the IP address of the destination. And then there's a sequence number, so it'll print out the sequence number. Time to live, which we're not going to talk about, but it's just know that it's one of the things that it prints out. And then the other thing it prints out for you is the round trip time in milliseconds. So how long did it take for the packet to go and come back? And then every 1 second, it will send another packet and another packet and another packet, and it'll keep going. And if you want to stop it, you have to press Control C. Okay, so it's essentially giving you the ability to check whether you can continuously send these ping requests. And it also gives you what? It also gives you a average, not an average, a ballpark estimate of the time it takes for that packet to get to the server, to the other end. Now it's not an exact time, and again, I'm not going to go into the details of why, but it's kind of gives you kind of a ballpark of what that latency is, and latency refers to how long it takes to get there and back. Okay, so this is the output, and we'll do this live in a second. But here's an example of a ping command. So the first thing is, you can see that when I tried to do this lookup, I actually tried to ping a DNS, sorry, a domain, a DNS address, domain name. So you can see it was a certain server at Amazon. Okay, so the first thing that ping does is it does a DNS lookup. So it resolved this IP or this domain name to this IP. Okay, and then you can see it prints out the number of bytes that it was sending. Okay, you can see on every line there's a time associated with the return the return time. So this is how long it took to go and come back, go and come back, go and come back. Okay, you can see it's not always the exact same time, and in some cases the jump is quite significant. And then at the end, you get an average of all of or a summary of all of the information. Some of it is average. So you can see here it's showing you the return trip time, minimum, average, maximum, and then the standard deviation. Okay, and if there was any packet loss. So packet loss, if you're pinging a particular server and you're getting some amount of packet loss, then there's something wrong in the connection between where you are and the server that you're sending to. So there requires some investigation. But you can see in this case there was 0% packet loss. Okay. So here's an example of pinging Clarusway. So again, you ping Clarusway, that's the IP that you get back. And then you can see it says reply 32 bytes. The time was 132 milliseconds, 130 milliseconds, and so on. Usually something around 50 milliseconds means it's really fast, it's good. Less than 50 milliseconds, at about 100, 150 milliseconds, it's fine for any sort of website, web data. And then, when you start getting more than 1,000 or more than even 500, that's really slow. And then you can see the round trip time and the average or the summary here. And then a similar output pinging Google. Again, I typed in, or whoever typed in google.com, you got the address, and then it starts pinging that address and gives you the statistics here. Okay. And in this case, you can see this is a ping directly to an IP address. Must have been the IP address from here. Somebody just used that. And you can see there's no DNS lookup then that's required. It's pinging that machine directly. So we can try that. So for those of you who had a different IP address for Clarusway, let's do that. Clarusway.com. And you can see. And this will just keep going and going. Okay, actually now I see, I think I understand why we're getting these different IP addresses, because it's using CloudFront, and CloudFront is a content delivery network. So it's got edge locations. And so depending on where you are, it's going to hit a different edge locations. That would be my best guess right now. But if you do this, the two of you who said you had different IP addresses, are you still seeing those same IP addresses?
Now, same IP addresses with you. Then I pinged.
And what if you do an NS lookup?
I'll try that again. Yes, I got this same IP address with you.
Huh, okay.
Interesting.
Yeah. All right, so there's that. And then let's try, if I do this, Amazon.com. Okay, so here's an IP address for Amazon.com. So instead of doing the NS lookup, instead of doing the domain this time, I'm just going to do a ping of the IP address. Okay, so you can see this time it doesn't have to do the NS lookup. It just does the ping of the IP address, and it works. And then if you want to see, there's a lot of different options you can use. Well, I mean, you don't use a lot of them, but there's one in particular, I think it's -C. Yeah, -C. So if you just want to send a specific number of requests rather than having it go nonstop, you can do a -C. Then it'll just print or go 10 times or 5 times. And then there's a bunch of other switches or options, which aren't particularly, unless you're trying to do some heavy-duty networking diagnostics, doesn't really come into play. All right, what about Etsy? I'm trying to find one that's going to block us. Everybody allows it these days. I'm trying to show that there are some IPs or some servers where, even though ping is not working, the server is still up. But it seems like all of these allow ping. But a lot of servers won't allow, not a lot, but some servers won't allow ping. The other one, remember I told you that your own server, if you want to loop back, is 127.0.0.1. So with this command, I just ping myself. Right? Look at the times. Very fast. So I'm just pinging my own machine. Okay, so that's ping. All right, and then we have SSH or secure shell. So what SSH is going to do is allow you to connect to a remote machine using this protocol, the SSH protocol. And again, like I said, because a lot of these servers are remote, you don't work in the same building or the same area where these servers are, you need some way to access them. And so when I access a remote server, it's as though I am on that server. So if I were to, so this is a picture. I don't have another server up and running right now, but this is what it looks like if I were to, this is somebody who has SSH'd, if you will, into a remote server. And it's like the shell, it's going to look just like this shell, except it's going to be, you're going to be on another machine, on another server that's away from you. So there's no difference whether you're sitting, you're connected to your machine or another machine in terms of the interface that you have. So all these commands that run ls, cd, make dir, all of that, if you do any of that and you're connected to a remote shell, you're going to be operating in that environment now, not in your environment anymore. Okay. And with Linux, a lot of times you're not using username and password anymore. You're using what are known as key pairs. Okay. And with key pairs, you get a specific file. It's called a PEM file, if you will, PEM. And you use that as your authentication mechanism. So the first time when you create a user or you create a key pair, you get this file and you keep it with you on your local machine. And then you use that as your authentication mechanism to log into this remote server. So essentially you're just doing SSH, you provide the PEM file, and then the user you're logging in at, and then the remote IP, and you can log into that server. In fact, we have a few minutes. I can actually show you. I can actually spin up a server. Probably have a. I think this was the last slide, so I have a couple of minutes. Let me show you. So I'll go to Amazon Web Services. So what I'm going to do is I'm going to create a server in the cloud for myself. And I'm going to then connect from my laptop, which I'm sitting on right now, to a server in the cloud. Okay. So I don't know how many of you have any experience with Amazon, but if you do, great. If you don't, it's not going to matter to this demo, but just know that what I'm doing is I'm creating another server in the cloud. Okay. Storage. I'm going to name the server so I know which one it is. And I have to tell the server to allow that I have to turn on the SSH protocol. In fact, I'll use that, show you how ping will not work here, because if I wanted ping to work, remember I said the ICMP protocol has to be enabled. So I would have to come here and I would have to turn on ICMP, but I'm not going to, and I'll show you how you can ping something, and even though it's up and running, that the ping doesn't return. Okay. So you can see my server here. Okay, it's still not running. It's in the pending state. But in the meantime, let me come here. Okay, so you see here's my PEM file. Those are my security credentials, okay, that I have already downloaded here. And what I'm going to do, it's running now. So here you can see I've got a public IP. That's the IP address of this server, okay? And this is the DNS name of this server. So if I do this, if I do dig, okay, so I did a dig on that name, and you see this is the address that came back. And you can see that's the address 54.87.202.235, same. So already the DNS servers are updated with that IP address. Okay, so now let me try and ping it. So ping. Okay, see nothing's coming back. So the server is still up and running. You can see that here, but ping is not working. Why is it not working? Because the remote machine, the server that I just created, doesn't have ping enabled. Okay, but now what I can do is I can SSH-I, and then I would do my PEM file. And then I have to do the username. That. And it's asking me if I want to continue. Oh, it denied me permission. Why is that? Okay, 1 second here. I don't know if maybe I used a different key for that. No, I think there's something wrong with this key file that I have here. Yeah, okay. Yeah, I'm not going to be able to show you, but essentially once I do an SSH into this server, then I would have a shell here that looks exactly like this, and I can run any of those Linux commands. But for some reason, I can't access it right now. That's right. Let me just check something here quickly if I can fix it. Yeah, no, that's the right command. Okay, anyway, I don't have the time to debug it right now, but that's essentially what SSH will do for you. And then the last command, we're almost out of time. The last command I wanted to go through with you is a very simple one. Who am I? So if you want to know which user you are in Linux, as you remember when you're talking about file permissions, you have the owner and then the group. And so if you want to know which user you are, if you correspond to that owner, you can do who am I, and you get the name of your user. All right. So that, my friends, brings us to the end of our Linux bootcamp. Like I said, I hope it was interesting and enjoyable for you. Good luck on your journey wherever it takes you. Wish you the best, and thank you very much. Have a good evening, and talk to you soon if you join another one of my classes. Good night.
Thank you.
Thank you so much.
Thank you so much.
Thank you very much.
Bye-bye.
Thank you.
Bye-bye.
I would like to remind to all our friends that we will post a survey on class chat. Please fill out the survey to help us improve ourselves. Thanks again, Altaz.
Yeah, thank you. Thank you, everybody. Bye-bye.